An important magnitude to analyze when we study the energy waste in transport is performance. The performance tells us the amount of energy that we are really using in the or really we destinate to the real movement or the real work that we want to do. And in this chapter we are going to analyze the performance of a vehicle. We will compare the internal combustion car with the electric car, but we will do it in the proper way. I will show you that in order to compare the real performance of a vehicle, it's important to consider from generation of energy to the final use. Because sometimes when we compare, for example, the electric vehicle, sometimes we miss some terms that are important, and this is what we are going to focus on this chapter. Well, the performance of a vehicle, and let's start with the internal combustion vehicle, tells you about the thing that we need to make a movement of the vehicle. The vehicle is using a part of the energy that is obtaining from the fuel to obtain kinetic energy of the vehicle. So we have a source that is our fuel that is burning, and part of this energy is converted into kinetic energy. But the performance, in order to understand which part of the energy is used, is the magnitude that tells us from all the energy that I'm really burning and really obtaining in the burning of the fossil fuel, which amount is really used in the question that I want, that is increase the kinetic energy of the vehicle. This is the useful work, because my machine is fabricated in order to do this work. The rest are the losses. The losses, you can notice that the losses are there because when you finish, when you use your car at the end of your movement, if you touch the car and the motor, you will see that this car is so hot. So you will notice that lost energy in form of thermal energy. And which part it's used? Then we have the performance. This performance is the question between the useful energy that we are using, so this part of here, divided by the total energy that I'm burning, I'm generating from my fuel. In an internal combustion car, these are the typical magnitudes that we have. Let's imagine that we use 5 kilowatt hours of energy, and from these 5 kilowatt hours of energy, at the end I will only use 1.5 kilowatts. These are just random numbers, but the fraction of the useful respect the total is more or less what you get on a standard car. This means that 3.5 kilowatts hour are really waste. Observe that you are wasting more energy than the one that you use. And this means if we make the quotient 1.5 divided by 5, that is the total amount that I'm using, I get 0.33. This means that I only use properly 33% of my energy. And it means that I'm just wasting 67% of the energy, more or less. These are approximated values. This means that if you do it in money, every $30 that you put in form of gasoline inside your vehicle, 20 are really burned without doing anything useful. Only one of the $30 are burned to do the proper work. This is a thermodynamic limit. You can difficultly go into a higher performance, So this is nothing that the vehicle manufacturers want, but it's there. And well, we have to consider this, that much of the energy that we are wasting it's just to heat the car. Okay, these are the numbers. This is the performance of my vehicle. Let's go to the electrical vehicle. The electrical vehicle uses the battery, and once again, the battery has an amount of energy that it's changed into kinetic energy in the same way as the combustion vehicle did the same with the fuel. And in this case, we have that the performance of the electrical vehicle is much higher. Why this change? This is for several factors. First of all, it's because the electrical motor is much more efficient than the combustion motor. You cannot beat with a combustion motor, you cannot beat an electrical motor. But there is also one extra thing that it makes the electrical car very interesting. That is that, remember that we told that there is a kinetic energy recovery system called KERS, that when you brake the car, instead of dissipating the energy, you are restoring the energy into your batteries. This is something that the combustion vehicle cannot do, because you cannot generate fuel from the braking of your car. It's impossible. It's something that you cannot do. But in the car, in the electrical car, you can brake, and with the motor, you can generate again energy. That this is what is done in the power plant. You are moving the motors to generate electricity. So this makes the two things, that the electrical vehicle is more efficient than the internal combustion, and the fact that you can recover part of the energy makes that the waste of energy is so low. So you can go inside the city a lot of time without losing your energy. At the end you will lose the energy, but not at the rate that the internal combustion vehicle do. But there is a problem. So from this point of view, it seems that, well, the electrical vehicle it's unbeatable. But we are not considering all the energy circuit, because when I have taken this vehicle, I have charged it from the network. So really, in fact, the energy is not coming from my vehicle and from my energy source, but it's coming from a power plant. And the power plant is generating the energy, and I have to consider the efficiency of this power plant, because the power plant is generating the energy from doing some process, that in the case that the process is done by a thermal fossil fuel plant, the efficiency of this plant will be more or less the same, like 40%, not it will not be 100%. And the second thing that I have to consider is that the electrical network, the electrical grid, it has also an efficiency. There are losses of energy in this transport of energy. So to get the final efficiency, the final performance of the vehicle, considering all the stages, the generation, the transport, and the use of the energy, in order to get this, I have to multiply the three values, 0.4 multiplied by 0.95 multiplied by 0.95. And if I do this, I get similar values than the internal combustion vehicle. Well, this is in the case that we are using a fossil fuel power plant. If we use hydropower, if we use solar power, the numbers would be very different. And the second thing is that using renewables, it's much better than using fossil fuels. So with this comparison, I'm not claiming that electrical vehicles and internal combustion vehicles are similar. No, just in the case that we are using fossil fuel plants, the performance will be more or less the same. But obviously, an electric car charged with renewable energy will be much better than internal combustion vehicles. Okay, let's finish with the conclusions. Increasing the performance reduce the amount of energy that I need for this activity. This is what we have seen. So performance is a very important magnitude to take in consideration. Remember that, for example, the performance of electrical motors is much better than internal combustion motors. So it's necessary to compare different mobility strategies, to compare all stages from generation to the use, the final use of the energy. And in order to increase the performance of our whole system, we need to consider all these stages.